Hey, boys and girls, it's Mr. Mac. Today we're working on lesson 17.4, which is dividing decimals with two-digit divisors, is what our focus is going to be today. We've worked a little bit with the single-digit divisors. Today we're going to focus on the double-digit. We are going to use what we learned in our last lesson as well, which was those compatible numbers to estimate, just so we can check our work, but also it's going to help us in solving the actual problem. You'll see what I'm talking about once we get there. All right, so problem we have here says a scientist collects a sand sample from the shore of a beach. He stores an equal amount of the sand in each of 38 containers. How much sand does the scientist put in each container? So obviously we've got all this sand, 23 and 56 kilograms. We're dividing it by 38 containers, so that's why I have the problem set up right here the way that I do. Okay, so it says to use compatible numbers to estimate. We love estimating. Show your work. So 38 would round to 40 because we said when we have two-digit divisors, we start there. Okay, and now we got to figure out what's around 23 and 56 hundredths to. Well, what I like to do is I like to look at this 4 and say, okay, well, how many times can 4 go into 23? I can go in 6 times, and that would make 24. So then I change this number just to be 24, just regular old 24. Okay, so now if I'm estimating with this, I need to say, okay, 24 in this problem divided by 4, right? So I know that 24 divided by 40 would be 6, all right? But I also know that 24 divided by 40 isn't going to be a whole number of 6, so we're going to have to put our decimal in here to make that 6/10, or also 60 hundredths, because if we're looking at this problem like 2,400 hundredths divided by 40 here, okay, we know that if we cross out our zeros as we've done this division before, that leaves us with 60, and we are dealing with hundredths. So our answer should be somewhere near 60 hundredths. Well, how is this going to help me in solving my problem in the first place? So when we're dealing with solving this problem in the first place here, okay, the nice thing is we need to figure out how many times 38 can go into 2. Well, 38 can't go into 2. Right? So then we want to see how many times 38 can go into 23. 38 can't go into 23. So then we want to see how many times 38 can go into 235. Well, now that we have this estimate here with this 6, the first thing I'm going to try out is 38 times 6 to see what that's going to give me. So I have 38 times 6. And I do 6 times 8 is 48. Carry my 4. 6 times 3 is 18, plus 2 is 22. That gives me 228, which is really close. So I put this 6 right here above the 5 because it went into 235 6 times, right? I subtract my 228 because these are my steps that I've learned in the past. Okay, and I'm running a little bit out of room here, but I can tell you that this would be 7. And then after I subtract, I need to bring down my 6. Okay, so then I need to see how many times 38 can go into 76. Well, 38 and 76 are pretty close here, so I'm just going to try 2 and do 38 times 2. Sorry for my sloppy work here. Okay, that gives me 16. 3 times 2 is 6, plus 1 is 7, so that gives me exactly 76. So it goes in 2 times. So I subtract the 76, and I get a 0. And then I bring my decimal straight up. So my answer would be 62 hundredths. Okay. Does my estimate tell me if this answer is reasonable or not? Yeah, because I had 60 hundredths. Okay. And my answer was 62 hundredths. So that means that my answer is very reasonable. I always love starting out with the estimates first because then this gives me this first digit I can start out with always. So let's look at some of these other problems here. So the next problem, it says, for a charity drive, 12 students collect aluminum cans to sell to a recycler. They agree to share the money equally. How much money does each student get to donate to their charity? So we had $82.44, and we were dividing that by 12 students. Okay, well, if we're estimating again, we could change the 12 to be a 10. And what's close to 82 that can be divided by 10? We could get 80. 80 divided by 10 gives me 8. So I know that my answer is going to be somewhere around $8. Some of you might be able to leave this 12 alone because you know your 12's facts really well. And you might have said, okay, well, I know that 12 can go into 84. And so maybe you changed this number to 84 and you did 84 divided by 12. Well, that gives you 7, right? So the estimates are still really close. As long as you're rounding a little bit, that is totally fine. But I prefer to make it a 10 just because that's a lot cleaner and a lot easier. So now we have our estimate here to solve the actual problem. I'm going to set it up like our long division problems that we've been doing. So $82.44. And I'm going to divide that by the 12. Well, depending on what your estimate was, 7 or 8, you could pick either one of these. I would prefer to start with the 7 because I like starting with lower numbers. So I do 12 times 7 is 14. 7 times 1 is 7 plus 1 is 8. So that's a little bit too much because we wanted to get to 82 and I got to 84. So I should try 12 times 6. Okay, 12 times 6 is going to give me 72. So that's going to work. So I'll put my 6 up top here. I subtract my 72. I get 10 and I bring down my 4. Now I got to figure out how many times 12 can go into 104. Well, I know that 12 times 7 here was going to be 84, so let's try 12 times 8. Okay, I like to leave my work right on the paper just in case I need it again. That gives me 96. If I was to add 12 more to 96, that would be 108, and that would be too much. So I know that the 8 works here. 8 times 12 was 96. I need to subtract. I can't do 4 minus 6, and I can't borrow from the 0, so he has to borrow from his neighbor. And then I borrow from this guy, and I get 14 minus 6 is 8. 9 minus 9 is 0, and then I need to bring down my 4. Well, if I look at my work from before, I see that 12 times 7 is going to give me 84, so I put my 7 up top. 12 times 7 was 84. I subtract, I get a 0. I bring my decimal straight up, and my answer would be 6 and 87/100ths, no matter how ugly it looks. So what does that mean? The question they asked was how much money does each student get to donate? They each get to donate $6.87 to their charity. Our estimates were 7 and 8, and that's really close, right? And we know that $7 is really, really close to $6.87. So this would probably be our most reasonable estimate. And it would be the most reasonable because we changed it the least, right? If you're looking for the most reasonable estimate, you don't want that problem to have changed much at all. All right, so again, you're still doing the same steps of divide, multiply, subtract, bring down, but with the estimating with those compatible numbers, that's a good way to help us know where to start in our long division problems, right? So if we're looking at number 8, which is going to be the last one we're going to solve, right, I would say, okay, 42 can round to 40. So in my head, I'm thinking, okay, look at the 4. How many times can 4 go into 33 without going over? Okay, it can go in 8 times, because 8 times 4 is 32, right? So if I'm multiplying by 8 here, then if I'm looking at the 8 times 4, that gives me 32. So for this problem, I would know to start out by trying to do 42 times 8, which would give me 16. 8 times 4 is 32, plus 1 is 33. That gives me 336, which is super close. So I know then the first number I would start out with would be 7. So 42 times 7, that gives me 14,294. And then I could go from there and say, all right, well, this is a 7 above the 1 because it's going into 331. I would subtract the 294 from 331. And then I would continue on with the regular long division. I'm obviously running out of space there, but just as an idea for you to know where to start. Using those compatible numbers is a really good way to help us start these problems. All right. Good luck with these problems. If you need a little bit more help, maybe watch this video again. Also check into math because there's other videos that are going to be posted. All right. Good luck, guys.